Okay, in the following examples, we're going to look at two different examples. One where we take the square root of both sides of an equation, and the other where we factor out the greatest common factor. All right, and in both cases, we'll be solving these equations for data between 0 and 2 pi. Okay, so let's start with this example. 1 minus 2 tangent squared theta is equal to negative tangent squared theta. Okay, now when I have something like this where it's just one unique trig term, right? They're both tangent squared theta, right? If this was tangent theta, I would take a different approach. But since they're both tangent squared theta, I'm going to group the tangent squareds on one side and I'm going to put the number on the other side. Okay. All right. So in this case, right away, I'm just going to add 2 tangent squared theta to both sides. All right. Here I get 0, so I'm left with the number 1 on the left side. And here I have 2 and then minus 1, so we're just left with a positive 1 tangent squared theta. Okay. All right. And now here, when we have a square, we just take the square root of both sides. Right? Easy enough, right? There's one little thing we do have to keep in mind, right? Whenever I square root a square, I always have to make sure that I include plus or minus. Right? So square root of a square, plus or minus square root 1, or plus or minus 1. Okay, now the reason for this, if we think in algebra, right, let's say we had an equation x squared is equal to 9. There are two values that work here, 3 and negative 3, right? Negative 3 times negative 3 is a positive 9, right? So the square has this value that when we take the square root, always include plus or minus so that you get all the solutions, plus or minus 3. Okay, similar to what we did here. All right, so here again, that plus or minus is simply telling me that there are two equations here, right? Tangent of theta is equal to 1, or tangent of theta is equal to negative 1. All right, and here, hopefully by now, this is an equation you can solve using the unit circle, right? When is tangent of theta equal to 1, right? That happens in quadrant 1 and in quadrant 3. With a reference angle of pi over 4, right? That's when they're both, the cosine and the sine have the same value. So theta is pi over 4, and then this angle, or the bigger angle here, is pi plus another pi over 4, 5 pi over 4. Okay? Now, again, that's only the first equation. For the second one, tangent theta equals to negative 1. Tangent is negative in quadrant 2. And in quadrant 4. Okay, again, when it's negative 1, that's when we have the sine and the cosine. The same value, but one's positive, one's negative. So that happens at 3 pi over 4. And then over here at 7 pi over 4. Right, and again, these values just straight from the unit circle. All right, so that means that our solution set for our original equation is pi over 4, 5 pi over 4, 3 pi over 4, and 7 pi over 4. Okay, and that's how we would solve an equation like this, where we just have one trig function, right? It's the same one, even though it shows up twice on each side of the equation, but it's the same one, right? And it's squared, all right? Very important. Notice that if we didn't put the plus minus here, this set of solutions, we'd have no way to find out that they were there. All right, so just keep that in mind. Okay, let's do another example here. So let's say we have square root sine squared theta minus 2 sine squared theta equals to sine theta is 2 sine squared theta. Okay, and again, similar to the previous one, I'm going to solve for theta between 0 and 2 pi. Okay, now here I see just one trig function, sine, but it shows up in different forms. Right? We have sine squared, and we also have a linear term of sine. All right, so when I have that, when it's different powers, I'm going to try to set this equal to 0, and then go from there. Right. Now the first step in doing that is I'm going to add 2 sine squared theta to both sides. All right, so that's 0, but that's also 0, so that simplifies it right away for me. So we have root 2 sine squared theta. That becomes 0. This equals to sine theta. All right. Now right away here, I want to urge you. I can see you're thinking about it. You want to divide by sine of theta. Please do not do that. Okay. Again, remember, when we divide by a variable, we may be dividing by a value of 0, and we can't do that, right? That's undefined. That's an undefined operation. All right. What happened if we divide by the sine theta? We will lose part of our solutions, and they just won't be available to me. All right, so I wouldn't even know that I'm missing them, and it would be an incomplete problem. Right? I wouldn't have solved it completely. I wouldn't have found all the solutions. So again, resist the urge here, right? Do not do that. Instead, subtract sine theta from both sides. Okay, now these are not like terms, right? Like terms have to have the same power, right? So when we're subtracting, we cannot combine. That's 0. Okay, and again, it's what I want, right? This is not quadratic form, it's failing that C there, but it does have a common factor, right? That common factor being sine of theta. So let me factor out one factor of sine theta. That means I'm left with root 2 sine theta, right? I factored out one of those signs. Here I factored out the only term here, so make sure you write a1 equals to 0. Right, and again, right, it needs to be equal to 0 so we can take advantage of that 0 property. Right, and what was that property? Right, we have two factors. Right, this is one factor right here, and this is the second one. Right, when I multiply them, right, when I multiply them, that equals to 0. That means that one of them has to equal to 0. So this will be true if sine theta is equal to 0, or this would be true if root 2 sine theta minus 1 is equal to 0. Okay. Okay. Oops. Equal to 0. So now I have two equations that I can solve independently, right? So I'll solve this one first. This one is easy. All right, for my unit circle, sine is 0 at angle 0 and at angle pi. Right, if I keep going, it's 2 pi, but that's, remember, not inclusive of 2 pi, so those are the two solutions. Okay, here, add 1 to both sides. So we get root 2 sine theta equals to 1. Divide by root 2. Sine theta is equal to 1 over root 2. Rationalizing the denominator, we get sine theta equals to root 2 over 2. All right, and I know again from the unit circle, theta is going to be, all right, this is a pi over 4 reference angle. So sine is positive in quadrant 1 and also in quadrant 2. So with a reference angle of pi over 4, the angle in quadrant 2 is 3 pi over 4. And now I have all the solutions. So our solution set is 0, pi, pi over 4, 3 pi over 4. So we have 4 different solutions here. Okay. All right. So let me, I'm going to reiterate here. Kind of one thing I mentioned earlier in solving this problem. I made a big deal out of not dividing by sine of theta, right? I see this pretty often. It's a very common mistake. We see that and you're like, oh, I can simply divide by sine theta. Okay. And then what we have here, we get root 2 sine theta equals to 1. Divide by root 2. We get 1 over root 2, which we know is root 2 over 2. Right? So I'll just do this. I did the work in the previous problem. I'll just take advantage of it here. All right. And then you say, all right, well, I know where that is positive, right? Root 2 over 2 is pi over 4 reference angle. Positive in quadrant 1 and in quadrant 2. And you're like, all right, that is it. These are my solutions, right? But again, right, I pleaded with you, right? This is wrong, right? Do not divide by a term, right? Do not divide with something that has the variable. And we can clearly see why, right? If you did this, you came across and you would have no idea that you're missing solutions. Okay? We saw in the previous, the correct form to do this, subtract sign, factor, and then set each one of those equal to 0, right? You lose completely out on this part of the solutions. Okay? So hopefully this, you'll remember this. You'll say never divide by any variable or never divide out a variable here. All right? Never cancel out or simplify these terms. All right? And that goes across any kind of algebraic equation, not just trig. Okay? So do not approach it this way, right? Common mistake, right? Look at it and remind yourself, say it out loud. Do not divide, do not simplify terms from both sides of the equation. Okay, thank you.